So yesterday we spent some time factoring quadratic expressions, and the big thing that we did was teach you how to do the Snowflake Method, which is, I found to be the more elegant and speedy method. While you were working through these ones, hopefully you recognized that as you did this, you got x minus 3 and x plus 3. And as you did this one, you got 2x minus 5 and 2x plus 5. Now, let's consider a pattern. How do I get from this right here to that right there? How do I get from my second term here, the 9, to a 3? What operation do I do? Square root. So here is the key that you recognize. Whenever you have a perfect square minus a perfect square, all you do is notice these terms are down here the same, except that one is negative and one is positive. Another way of calling that is to call it conjugates. So let's go ahead and write that word down, conjugates. And a conjugate is simply the exact same numbers, except the inside is positive, inside is negative. So we're not saying opposites. Just saying conjugates, where the operation inside changes. So the shortcut here, and it's called the difference of two squares, is that if you have a perfect square minus a perfect square, so a squared minus b squared, the difference of two squares factors to the product of conjugates. It's simply, and it's as simple as this. You square root that, and you square root that, and then you conjugate it. So if you recognize a difference of two squares, then there's no a snowflake, there's no grouping method, you just jump straight to the answer. Jump straight to the answer. Oh, so look at this one. I see I have a perfect square because of the 2, and a perfect square here is 36. So what do? I square root that, I square root that, and exactly write it again. And one is positive, and one is negative inside, also known as the sum and difference. That's it. It's about recognition. No crazy work, just recognition. And notice that your perfect squares don't have to be simple perfect squares. They can be ugly looking. Look, 25 and x squared is a perfect square, 5x. 81 is a perfect square, it's 9. So there we go, 5x plus 9 and 5x minus 9. Oh, but Swenson, up here you put the negative, the minus first, and then the plus, and down here you put the plus and the minus. It doesn't matter. It doesn't matter. The idea is because this times this, and you can flip those around. So called the sum and difference pattern by some, also called the product of conjugates, or sum and difference pattern. So we're just, not sum and difference, but difference of two squares. Now let's look at one other pattern, and most of us kind of look at this and say, looks like my math book threw up, and it's all this, and it's really kind of tough to recognize, because what you have to do is see, I have a perfect square there, so this is perfect here. And then I notice that I have a perfect square also. Perfect is here too. So that's kind of hard to recognize. And then this one's, what does that mean? That means it's double the product of the other two. So that's kind of hard to recognize. So, but the key is to look for the front, the first and the last, kind of. Are those perfect squares? So then if they are, then there's a good chance you can just jump straight to the work. So how to do this one? Well, it's merely a matter of square rooting this, square rooting the last one, and whatever symbol is right there, just bring it down. And when I say square root, I messed up. That should be a square root there. And let's just look at another pattern here. I do notice that this one's a perfect square in the front, so if I square root that, I get 3x. I notice that the end is a perfect square, so if I square root that, I get a 2. And essentially all you do is bring down that plus right there, and put the squares around it. This right here should actually be a 12. For the pattern to work, I messed up. And now the last thing I want to show us is to factor completely. Factor completely. Yesterday, our first step was, what we wanted to do was make sure to always check, number one, was to factor out any GCFs. So I wanted to get us in the habit of reading that so that when we approach a problem like this, GCF is always the first thing we check. So if I look at this first problem, I notice that I have a 2 in the front, and this is even. So I can factor out a 2. Now, once I factored out the 2, I recognize that inside the parentheses is a difference of 2 squares. So I'm going to bring the 2 down, and I'm going to factor the difference of 2 squares as their conjugates. And I'm done. Now, sometimes inside the parentheses can be factored more. In this case, I used a special pattern. And sometimes you have to use Snowflake or something like that. So notice in this one here, 6, 15, and 9. 3 is correct, so let's pull out a 3 to get 2x squared plus 5x and minus 3. Now inside, this 2 is not a perfect square. So I can't use any of the patterns I just learned. So because of that, I'm just going to set up Snowflake for the interior, ignoring the 3 on the outside. So a times c, 2 times negative 3 is negative 6. I'm going to put 5 on the bottom and flank with the 2x's. So what are the factors of negative 6 that add to positive 5? That would be 6 and negative 1. It's tempting to say 2 and 3 on that, but one of these has to be negative and one of these has to be positive. So let's see, I can reduce this one to be x over 3. So there's one of my factors. So I bring down the 3 and I bring over the x plus 3 and then the 2x minus 1. So what were my steps? Number 1, I factored out the GCF right here. Then number 2, I recognized this as not a special pattern, so I just used Snowflake to see if I could do it. And I did, so I'm done.